All right, guys, here we go. Test 16 review. Number 1 says sketch the graph of the quadratic function. You need to put it in standard form first. So I'm going to factor out the negative out of the first two. Leave some space so we can complete the square. So if we complete the square, half of 4 is 2. 2 squared is 4, so I'm going to add 4 there. Really, though, I made a mistake. This should be a negative sign, not negative x. Sorry about that. Really, that's a negative 4 because of the negative sign in the front. So I'm going to add another 4 out here. So this is what I'm getting. Getting x plus 2 squared plus 8, which means my vertex is at negative 2, 8, which is way up here. Because the negative's in the front, it's going to open down. I need to find my y-intercept. Now, my y-intercept is 4. Knew that from the beginning. And because it's 4 there, and that's 2 over from that vertex, I can also go 2 over that way because it's symmetric. And draw my parabola. So tomorrow I need to see 3 points on your parabola there. Number 2, find the max or minimum value. That happens at the vertex and also domain and range, it says. Because it's positive, that means it's going to be a min. It means that the parabola opens up. One other way we found to do the vertex is we did negative b over 2a this week. Negative b would be negative 6. 2 times 2 is 4. That gives me negative 6/4, which is really negative 3 halves. I need the y coordinate, though. The y coordinate is what I need. So to figure out the y, I'm going to take that negative 3 halves and plug it into that x and that x. And I punched that in my calculator, and I got negative 23 halves. Okay, so now we already said because this is a 2, positive 2, it's opening up, which means there's a min. And the minimum value is the y coordinate, which is negative 23 halves. The domain for every parabola that opens up or down is all reals. And the range, because we're opening up and we have a minimum, the range goes from, and it's the y, remember, goes from negative 23 halves to forever. So the domain is the x, how far it goes left and right. The range is the y, how far it goes right and left. All right, number 3, express it in standard form, find the vertex, find the intercepts. So standard form, just like we did number 1, you have to factor out the negative 3 out of the first 2. Like that. Complete the square, which means I'm going to put a plus 1 there and a plus 3 out here. Plus 3 because 1 times negative 3 is negative 3, so I had to add a positive 3. So I get negative 3, x plus 1 squared plus 1. That's standard form. So here's what I know so far. I know the vertex is negative 1, 1. I know the y-intercept. When I started the problem, I knew the y-intercept is always that last term, negative 2, the constant term. The x-intercept's a little tougher. The x-intercept, I actually have to put a 0 in for the y and solve. So first thing I'm doing is putting a 0 over there. Move the 1 over, which is negative 1. Divide by 3, I get 1/3. It's 1 squared. I got to take the square root. If I take the square root of 1/3, I get plus or minus 1 over the square root of 3, which is really square root of 3 over 3. So I'm going to move the 1 over. So my x-intercepts would be negative 1 plus or minus square root of 3 over 3. Those are the two x-intercepts right there. Remember, x-intercepts are zeros or solutions. You actually have to solve the problem. So that problem's got a bunch of answers. I circled a bunch of stuff. Standard form, vertex and y-intercept, and x-intercept. Quite a bit. Number 4, find the maximum values of the function. It's got, let's see, I'm seeing 2 maxes. One of the maxes is at 0, 0. The other max is at 3, 1. It also has 2 mins, minima. One of them is at negative 2, negative 2. The other one is at 1, negative 1, looks like. That's all you got on that one. Number 5, find domain and range. This is what we just did. Okay, so some of these problems kind of repeat themselves. So if you know what you're doing, it should be in good shape. I need the vertex though. So I'm going to do the negative b over 2a again. So I'm going to go negative 4 over 2a. A is negative 1. That's just going to give me 2. That's the x coordinate. If I plug in 2, it would look like this. Negative 2 squared plus 4 times 2 minus 3, which would be negative 4 plus 8 is 4 minus 3 is 1. So what I really need is the 1 right there. Because the domain of every parabola we did is all reals. How far does it go left and right? Forever. The range, because this opens down, that means that vertex is actually a max. So it's going to go up to 1. The biggest y value is a 1. So the range is going to go from negative infinity to 1. It actually touches the 1, so you get a bracket there. Okay, number 6 and 7. sketch the graphs by transforming, indicate all x and y intercepts. Okay, so first of all, I know that number 6 is the parabola because it's x squared. It's been shifted left 3, there's the x-intercept. To find the y-intercept, remember, put 0 in for x, and if you do that, 3 squared is 9, so my y-intercept is 9. And because it's squared, it bounces off that 0, so I know it's gonna come. And because it's even, the left end goes up, the right end goes up, so it's gonna bounce off the 0 and come up just like that. Number 7 is, first of all, been shifted down 4 because of the minus 4, so it's going to go down 4. The y-intercept is -4, which we just then found. Let's see here. I need the x-intercept, so I have to solve it to get the x-intercept. So I'm going to do this, -x cubed minus 4. Let's move the x cubed over. Make it x cubed equals -4. So x is the cube root of -4. That's going to be my x-intercept. I'm going to punch that in my calculator real quick, just to see about what decimal that is. Okay, it's about -1.59. So I want to go there for my y-intercept. Sorry, for my x-intercept, -1.59, about right there. Now don't forget what this is. This is in the cubic graph, and it's odd. So it's odd and negative, which means it's going up, left, down, right. Starting from here, that first point we do was the vertex point. So it's going to go up like that, do the x-intercept, and then down like that. Number 8. Sketch the graph. Make sure we get the right end behavior. Let's put the zeros on here. I got -3, +2, +4. Let's find the y-intercept also. Put zeros in everywhere. So it's going to be 3 times -2, which is -6, times -4, -24. Are you kidding me? Yeah, way down here somewhere. So your y-intercept's way down there. And because there's 3 x's, it's odd. So it's coming up from the left. Okay, wait a minute, something's not, oh, that's what I did. The y-intercept. The y-intercept, I'm multiplying 3 times -2 times -4. That's actually +24, which is way up here. So it's gonna come up from the left. It's gonna go way up there, come back down, cross again, boom. Just like that. Number 9. 9, you got to factor first. So what I'm going to do for 9 is I'm going to factor out the x squared, which will leave me x squared minus 3x plus 2. Keep factoring. That's going to be x minus 2, x minus 1. Don't forget the x squared. Hint, there's this x squared. Oh my gosh, these are going to be very close together. Let me make this a little bit bigger. All right, so I'm going to have a 0 at 0, and a 1, and a 2. And because the x is squared right there, it's going to bounce off of the 0. At x squared, which is 0. So it's also even and positive, so both ends go up, left, up, right. So it's coming down here. It's going to bounce off the 0, go back through, and there you have it. Notice both ends are going up. If it wouldn't have bounced, it wouldn't have gone back up. Number 10, determine end behavior. You can always start these off by going x is going to the negative, which means left, and x is going right. Okay, I'm looking at my leading coefficient, or leading term. It's odd negative. Odd negative means up, left, down, right. So up, left, that's left. I'm going up, left, and down, right. Sorry, they're doing that one. Number 11, determine how many local maximum minute this function has. All you gotta do in this one, guys. First of all, the most it could have is 3. It's gonna 3 at the most. It may have 3. It might have 2, 1, or 0. But the most it can have is 3. Let's just punch in the calculator and see how many it's got. Let's punch it and graph it. Okay, I punched it. My graph looks similar to something like, let's see, something like this. Which means it's got 2 mins and 1 max. So it is 3 altogether. So altogether, how many? Or if you want to make it specific, you can say, well, it's got 2 mins and it's got 1 max. That may be even better to write it like that. Number 12. Factor this, and then use the factor 1.5. Okay, we just did one of these a minute ago. One huge piece of advice on this one: anytime there's a negative in the front, you have to factor. I would always factor out the negative along with the x. So when I start this one, I'm going to factor out a negative x, which is going to leave me an x squared minus x. It changes all the other signs. So when I factor some more, I get x minus 4, x plus 3. All right, so my zeros are at 0. Got +4 and -3. And when I started, I noticed it was odd negative, so I know it's going up to the left and down to the right. Also, I don't have to worry about the y-intercept because it crossed at 0, the x-axis. If it crosses at 0, remember the x, that's the x-intercept and the y-intercept. So I'm starting up left, boom, boom, boom. And there you go. And the last, no, that was the last one, 13. 13, a manufacturer finds that the revenue generated by X units of a commodity is given by that function. By the way, guys, that's a quadratic. It's a parabola, all right? So, yeah. Where the revenue of X measured in dollars, what is the maximum revenue? Now remember, the maximum occurs at the vertex. How many units should be manufactured to find the maximum? So it's basically asking you, what's the vertex? So I'm going here, I'm going negative b over 2a. Be careful though, the b is actually the 80, so I'm doing negative 80 over 2 times negative 0.4. I'm gonna punch that in real quick, and I get 100. Now that's the x coordinate, okay? To get the y coordinate, I'm gonna put the 100, put it right back in there where the x's are. I'm doing 80 times 100 minus 0.4 times 100 squared, and that's giving me 4,000. Okay, so here we go. X is how many units? It says X units. So how many units should be manufactured? Should be 100 units manufactured. Then it says what is the maximum revenue measured in dollars? $4,000, because that's the vertex. That's the maximum point. That'll be like on your test tomorrow too. It'll be a parabola problem. 14, find the coordinates of all the extrema. So this is your left bound, right bound on your calculator. I'm gonna punch in my calculator, do my left bound, right bound. When I do make sure you have to fix your windows so you can see them. Adjust your X min and X max and your Y min and Y max like you need to be able to see the stuff. And then let's see what happens. I'll tell you what I did after I graph it here. Okay, I could actually see the max and the min in my window, so no big deal there. The weird thing is my max. Okay, I don't know just to throw you off or anything, but the max on my calculator says this. It says negative 1.378 e to the negative 6. That, and we're only going 2 decimal places. That e to the negative 6 means I have to move my decimal place 6 units to the left, 6 spots to the left, which is going to be a whole bunch of zeros. So if I round it to 2 zeros, I'm just getting 0. My other one says, my y says negative 5.7 e to the negative 12, which means the same thing. I have to move it way back there. So the estimate's 0, 0. Now, let me tell you this. Your calculator is basically saying it's not exactly 0, 0, but it's really, really close. So let's find the min. All right, and for the min, my calculator's telling me 1.9999999. So if you round it to 2 decimal places, it's going to give you 2, and it tells me the y is just plain on negative 4, no decimals at all. So there's my max, there's my min. That's all you got to do. Hope you're good on those calculator steps. All right, no review tomorrow. It's the first test of the semester, so get off to a good start. It's important. All right, see you tomorrow.